Okay, the first one is extract. In providing highest product and service aspiration in increasing market share as well as continue to compete among manufacturer in ensuring customer satisfaction is and prices. The main purpose of the study was to demonstrate Taguchi fractional factorial experiment for product design. The application of the Taguchi approach to parameter design for this study to determine the level and factor actually influence quality characteristic and from intuitive. Therefore, we propose criteria for selecting the adaptation factor. The main goal of this experiment was to design an airplane that could fly several fall and be anion. There are 4 factors to consider: weight, position, and stabilizer fall, nose distance, and wind angle. The exercise has provided an opportunity to conduct experiment to test the effect of 4 factors on the flight distance of a paper plane, each of which has 3 stages. A total of 45 experiments need to be performed in this experiment. Repeat the experiment 5 times to understand to change needed. The effect of each factor can be determined using a carefully defined subset experiment was performed and the results were validated. Concepts such as quality should be planned into product quality loss function, defining tool or method for robust design, designing product and process that are insensitive to the influence of uncontrolled factor or noise, signal to noise ratio, and organelles adjustment between terms important in application of the experiment method of the Taguchi method. Okay, second, introduction. The chapter represents the related research and literature from previous study. The definition of term also provide for better understanding. Besides that, the application of Taguchi approach to parameter design will be explained in this chapter. This project is about using Taguchi approach to conduct an experiment about paper airplane. Genichi Taguchi contribute on quality philosophy and quality tools, where it has to focus more on making quality rather than expecting quality. The main purpose for this study is to demonstrate a Taguchi fractional and experiment for product design. The application of Taguchi approach to parameter design for this study is determined whether a level of factor really affect quality characteristic is far from intuitive. Genichi Taguchi method can ensure the quality of design through 3-step approach: system design, parameter design, and tolerant designs of a strong and good product, and the process design. System design, prototype product considered to need a customer and capabilities of the manufacturing environment. Parameter design, identify setting for product process factor to improve quality and minimize sensitivity of the design of source of random variation. Many applications are too confused to repeat in classroom, why the Taguchi put into use in the industry. Some experiments have been made to exploit the actual case for classroom discussion, but they are profession and so requisite the technical especially to compare this. However, the most important is an exercise that guidance can apply to explain about Taguchi method. The paper airplanes experiment was first scheduled for a graduate course in quality at North Carolina Agriculture and Technical State University in Greenboro. This experiment only need easy tool and material that include paper, scissor and measuring tape. This experiment total take about 5 hours to present the experiment and collect the data from the experiment. The conductor and has a prepare a background in Taguchi method before study proceed to experiment.
Hi, Assalamualaikum. My name is Muhammad Irfan bin Hasri. My tick number is 270614. I will present about a literature's review, the Taguchi philosophy, Taguchi method for robust designs, and the last one is the concept of a loss function. Taguchi philosophy. Manufacturers are competing fiercely to meet the needs and expectations of customers. The application of statistical and experimental techniques is not widely used in industrial organizations. In general, many manufacturers are unable to use experimental design to make a high-quality product. Try and error is still the best approach to use. A conventional experimental design is a very complex and expensive process that requires competent resources and incur high experimental costs. It is complex and not easy to use, especially when the large number of experiments has to be carried out when the number of the process parameters increase. Melbourne, ETAL, 2007. Next, Taguchi method for robust designs. Taguchi improves a design quality control in the manufacturing process. This also proves that quality change is the main enemy of quality engineering and should be avoided. In a perfect design cannot be without the parametric method of Taguchi. Perfect design is also similar to parametric design, but in a broader sense. In part of a robust design, it is important to use this approach the schedule efficiency, qualities, and cost optimization. It also used S per N to predict quality from the customer's points of view. Taguchi's robust design approach will allow greater manufacturing tolerances, lower materials, and a wider operating environment. From Packard 2008. The last one is a concept of a loss function. In its loss function methodology, the Taguchi method demonstrates more precisely how to calculate the quantity of cost gains. The savings are calculated by using a loss function formula that takes into account the cost of a failure and the MSD value. The deficit becomes bigger and greater as the value divides from the target value. According to the Taguchi loss feature, prioritizing quality work is dependent on the maximum difference between the current method and the desired specifications. Taguchi proposed that the larger the difference from the target, the higher the probability of a failure and the higher the detect rate and a quality cost. From Heller's ETAL 2006.
Hi, my name is Hasha Najwa 263489. So for today, I will be presented about the methodology for this experiment. So the purpose of the experiment is to design Taguchi airplane and to demonstrate a Taguchi fractional experiment for product design. And it have been considered for 4 factors, which are position of the weight, stabilizer fold, nose distance, and wing angles. The material that used for the experiment design are Taguchi airplane template, paper clip that use a standard size, masking tape that measure flight distance record, and design analysis tablet. Okay, so the method is we will place the masking tape on the floor to design the lancista at least 30 feet perpendicular, and each participant take one paper clip and one Takuchi airplane template and written the data at the space provided and circles the appropriate level of each of the four parameters corresponding to the assigned experiment. With the print side face down, the template fold in half along the central line, then open it back up. So basically, this is the how we will fold our airplane. And what what we want to approach is we want to approach by create by Taguchi for product airplane is to signal the noise, and this is the formula that we use to signal the noise. Okay, how to approach this experiment is that each factor level combination, the signal to noise, is computed such that the formula use basic 10 log. Second, in each experiment, the mean equal to of the trial number, and S2 equal to standard deviation from the test in each experiment must be calculated before the SN can be calculated. Third, we select the optimal outcome for Taguchi airplane design with this SN formula. And lastly, number 4, the nominal in is the optimum signal to noise ratio to analyze or detect scaling variable which differ proportionately in average and standard deviation. So that's all for me. Hi, my name is Hasha Najwa and I will talk about the data analysis for the experiment. So Table 1 shows the Takuchi airplane flight distance record. This is the record after we have done our experiment. And Table 2 shows the Takuchi airplane design analysis table, which we have calculate all the mean distance, all the standard deviation, and all the SN. Table 3 shows the Takuchi airplane design analysis table. And to find the best combination, we need to see class by class. So for the class A, the highest distance mean is 4.02. The lowest for standard deviation is 0.06, and the highest for ratio means is 37.33. For the class B, the highest distance means is 4.10. The standard deviation that has the lowest is 0.14. And lastly, the highest for ratio mean is 29.40. For the class C, distance mean, the highest is 3.69. The lowest for standard deviation means is 0.14. And the highest for SN ratio for class C is 31.41. So lastly, for the class D, distance mean that have the highest point is 3.68. The lowest for standard deviation is 0.23, and lastly, the highest for ratio mean for class D is 31.47. So the result is from the 4 classes, we have choose the class A is a better Taguchi airplane design because class A have the highest distance means, the lowest standard deviation means, and the highest SN ratio. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Umar Zaki bin Dalil, number matic to 62473. I will present about discussion part and conclusion part. Alright, I will go to the first question in discussion. The first question is, what can you say about the effects of the different factors on flight distance? What levels of each factor would you use to maximize flight distance? There are four different factors on flight distance that need to be considered in order to do this project, which is position of the wing, stabilizer foil, nose distance, and wing angle. Each of the factors placed at different level, which is at level 1, level 2, and level 3. The effects of the different factors on flight distance can change the input of the data that we need to record. Based on the input above, the maximum flight distance for the wake location show that level 2 is the best, which is 4.02. For the stabilizer setting factor, level 1 is the best maximum flight distance at 4.10. Meanwhile, for the nose length show that level 1 is the ideal at 3.69 for the wing angle. For the wing angle, level 1 also show the maximum flight distance at 3.68. Next, I will go to the second question. What can you say about the effects of the different factors on variation in flight distance? What level of each factors would you use to minimize variation in flight distance? Standard deviation means calculated to find which parameter setting is most robust to noise. After we record the final calculation, it shows from the table above the level of each factor we'll use to minimize variation in flight distance. In first factor, which is wake location, show that level 1 is the highest at 0.47. Meanwhile, for the stabilizer setting at level 2 have highest record, which is 0.33. Factor nose length show the highest at level 1, which is 0.31, and for wing angle factor show at level 3, which is 0.27. The results show the lowest standard deviation mean is the most robust to noise. Alright, we'll go to the third question. The third question is the SN ratio a reasonable way to capture both goals to maximize distance and minimize variation? Can you specify an optimal design? Why or why not? Uh, from the data that shown and the table above, signal to noise ratio are reasonable way to capture both goals, which is maximize distance and minimize variation. We can see from the data for the factor of wake location, A2 37.33 is the best average SN ratio at level 2, and for the value is A2 4.02 at level 2. Meanwhile, for the factor stabilizer setting, B1, which is 29.40, is ideal average SN ratio at level 1. Value show B1 the best, which is 4.10. For factor of nose length, C3, which is 31.41, is the best average SN ratio, and for the value is level 1 at C1, which is 3.69. Lastly, for the factor wing angle, level 2 at D, 30.47 is the best. Next, I will go to the conclusion. For the conclusion, the process of selecting products important parameters is called parameter design. Parameter design involves finding the optimal settings of controllable factors in a product's design so that the final design is robust in the face of a variety of controllable factors. Controllable factors are those design parameters that need to be optimized. These factors should be specified on production drawings or specification sheets. For our case, uh, the controllable factors of the project are position of the wake, stabilizer fall, nose distance, and wing angle. Uncontrollable or noise factors can influence the result of the flight distance that might include height of the participant and the surrounding environment. The end result that we have been calculated show that Class B was chosen as the best of Taguchi airplanes design with the 4.10 of distance means, 0.33 of standard deviation means, and 29.40 of SN ratio means. That's all from me. Thank you for watching.